we see is that the fact that we have these two separate brains and that they work together, anything that disrupts that timing, again, affects what makes our brain unique. And the fact that we have all these different centers, again, we don't start out that way as children. We build our brain from the bottom up. As the child is growing, it's like a flower where it starts just as a stem. And then as it grows larger and longer, it grows longitudinally, and then it blooms out at the top like a flower. And that's what our cortex blooms out. And our frontal lobe is the ultimate blooming of that flower. But it takes a while to get there, and if anything disrupts that development on its way, then we may not get to where that area completely blooms, and the brain doesn't become specialized, and we don't develop all these specialized centers, and we can't coordinate them, and that's what creates this disability that we see in these children. And again, it really comes down to understanding whether the right side is delayed and the left side isn't, or the left side is delayed and the right side isn't. So what we see anatomically in these children consistently is that the bridge between the two hemispheres, called the corpus callosum, is in general thinner or less developed in all of these children, in autism, dyslexia, ADHD, OCD, Tourette's. Now, it's not because it's damaged. Again, it's not that this is a defect they're born with. It just seems that the wires aren't crossing to the other side. A guy named Donald Hebb, who was a famous psychologist from France, Canadian psychologist in 1949, actually made a statement, and he was one of the fathers of neuroplasticity, or the way that brains grow and develop. And he said cells that fire together wire together. So that cells that could fire together at the same time then grow connections to one another. But if they can't fire together, then they won't wire together. And it's not because they can't, it's just that they're not going to waste energy and resources on building connections to something that they're not talking to, right? It doesn't make sense. It's a waste of time and energy. We're doing a lot of this research ourselves. We're doing one of the largest studies on autism right now in one of our labs. And what you can see is, this is an MRI of a child with autism. And what is colored here are the connections in the brain, between the brain and within the brains. And what we see is that if you look at this, just looking at the right side and the left side compared to one another, you can look and see that the density of connections looks different, that there's clearly a difference. But just looking at a picture doesn't tell us everything, because if we see less or more connections in an area, or an area is bigger or smaller, or there's more or less electrical activity, that tells us something. But it doesn't tell us, what grade level they read at. Do they have normal eye contact? Can they socialize normally? What's happening in their digestive system? So we need to also measure those functions. So in Brain Balance, what we do is we actually have put together an extensive assessment that really measures the functions of all of these things, of visual processing and auditory processing and academic skills and motor skills and immune function and digestive function and their behavioral management and their socialization skills. We measure all those things objectively, because that's the only way we can really look at what's happening. And what we're looking at is we're measuring those on a maturity level, on a grade or age scale. Because essentially, like I said, what this really comes down to is that we're looking at areas of the brain that are growing at a different rate than others. And that's the problem. The fact that certain areas of the brain are not being stimulated in the right way, they're not growing fast enough to keep up with the growth in other areas, especially if children are gifted in specific areas of the brain. So we measure those functions because we can extrapolate out. We can say that if a child is reading at a certain grade level, then we can say that that area of the brain physically looks that size. And a study was done a few years ago looking at children with ADHD compared to typical children that were 10.5 years of age. And what they found was, when they measured anatomically 40,000 points on the brains of all these children, they found that the children with ADHD had brains that looked like 7.5-year-olds. They were 3 years physically smaller. And so that's what we're looking at, that the brains are physically and developmentally immature in certain areas where other areas may be actually advanced. And this is another thing that really stands out in these children, is the fact that they have this unevenness of skills. They don't have everything delayed equally. They may have certain skills that are much better than others, or they may actually have superhuman skills on one side along with really deficient skills on the other side. And the pattern of this is always the left brain is really super good in ADHD and OCD and Tourette's and autism, and the right brain is usually poor. And in dyslexia and learning disabilities, it's the exact opposite. There's a pattern, and it's not coincidental. It's because this is the problem. This is another study that was in Cerebral Cortex, a big journal, came out a couple of years ago looking at, and again, what they talk about here is that there's a problem with significantly reduced interhemispheric connectivity in the brain. And again, this is really what we see as the primary problem. So the makeup of these problems and the combination of symptoms that these children present with, or strengths and weaknesses, really comes down to they have certain skills that are really good or are better on one side of the brain or more mature, along with other skills that are very delayed on the other side. And the only difference between some of these disorders is really the severity of the imbalance, or how much of the brain or how many areas of the brain are involved. ADHD, OCD, Tourette's, PDD, Asperger's, oppositional defiant disorder, we see there's a delay on the right side, and they usually have advanced left brain skills. Dyslexia, learning disabilities, processing disorders, it's usually the reverse. So this may still sound a little bit confusing, so let me use an analogy that I've come up with that really explains it, because I've said a couple things that might sound contradictory. One is I've said that all these children have the same underlying problem, but I've also said that they're all different from one another. So how can that be? And the other thing, it may sound too simple, because you may say, oh, that's pretty easy. All we have to do is stimulate the right brain or the left brain and you fix the problem. So why doesn't everybody do that? It's not quite that easy. It's a little bit more complex. Again, I'm oversimplifying it and overgeneralizing a little bit because of lack of time. But let me give you an analogy. Imagine that you're a symphony orchestra, and we have 100 instruments on the left side of the room and 100 instruments on the right side of the room. And you're all great musicians, and you have your instruments, and I'm the conductor, and we know that to play a beautiful symphony, you're almost never going to play all at the same time, right? Certain instruments are going to play on this side of the room, and together with one another, they're going to join up with instruments on this side of the room. They're going to rise above the rest. They're going to come together for a few moments. They're going to break up, and then other instruments come together, and they break up. And what we hear is music. We really can't see it. We can't really measure it per se, but we know that it comes out of that combination of what's going on. And we know that it's not just important to play the right instrument or the right note, but what's most important is to play it at the right time. That we need to play in this type of rhythm with one another or at the same tempo. So imagine that I'm the conductor and I say, you know what, something sounds off. I can't pinpoint it. I don't really know where the problem is, but I know that there's a problem. Somewhere, some of you are off tempo, and I can't figure it out, so let's just try to drown it all out, and everybody play faster and louder, okay? Would that actually fix the problem? And the answer, of course, is no. It's kind of covering it up. It may make it less noticeable, but I don't really deal with the problem, right? That's essentially what medication does. Medication just kind of makes the whole brain kind of play louder and faster, and it just kind of drowns it out, but it really doesn't deal with the problem. And it never really will, and everybody recognizes that. So if I wanted to deal with the problem, I have to try to look into it more. So let's say I'm going on, I go, okay, I got a better sense here. It's the right side of the room. You guys, somewhere here, some of you guys are playing too slowly somewhere. So I'll tell you what, just the right side, you guys all play louder and faster, all of you. Now, is that going to make the problem better? And the answer is no. It's probably going to make it worse, because now we're going to take all of the instruments and make them play off tempo where maybe only a few were before. So it's